Good morning, eighth grade. We are now beginning module 3, and which is unit 3, and this is all about relations and functions. And our first module is module 3.1, and representing relations. That is what this lesson is all about. So let's look at our learning target. I can represent relations, interpret graphs of relations, choose and interpret appropriate scales for the axis and origins of graphs. So we have several vocabulary that we are going to be covering. Relation, domain, range, mapping. Of course, we are graphing, so we've got to know the coordinate system. And so let's start with an example that I have put up on the board, all right? And we're talking about a number of minutes you spent driving, all right? And so you can use math to represent the relationship between two sets of numbers. And for example, in this case, suppose you recorded the number of minutes you spent driving for your driver's training course each day for a week. Okay, so each day for a week. You may use the set. This is for days 1, 2, 3, 4, 5, 6, 7. This is representing the days. And this other set is representing the minutes that you spent driving. So the relationship between the sets pairs each day with the time driven that day. And this pairing of the numbers, okay, pairing day 1 with the minutes, day 2 with how many minutes. So this pairing of the numbers is called a relation. And the set of days, this is the domain, okay, so this one is the domain. And then we have the relation, so the set of days is the domain of the relation, and the set of times, this one is the range. This one is the range. So a relation is a set of ordered pairs. So for example, in one day, you do 30 minutes. In day 2, 45 minutes. So it becomes a set of ordered pairs that we have. And the set of the first numbers of the ordered pair in a relationship is called the domain. So the first set is called the domain, and then the set of second numbers of the ordered pair is called the range. Okay? And a relation can be represented in multiple ways. We can do a mapping, which illustrates the relationship between the domain and range by showing how each element of the domain is paired with an element in the range. An equation shows the relationship between the domain and range of a relationship, where substituting each value in the domain for x results in the corresponding y value of the range. So I'm going to go ahead and talk about domain and range and how we are going to map it or make a table or graph it or write an equation. So there are so many of these ways that we are representing those relationships. Okay, so let's talk about the x values in the domain, and the resulting y values can be written as ordered pairs and are called solutions of the equation because they make the equation true. All right, so let's say I give you this set of ordered pairs over here. So the first way that I'm going to represent this relationship is with mapping. Okay, so it's also called a mapping diagram. So I have mapping. That is my first method. So I am going to, you can make an oval, or you can make, doesn't matter. You can make a rectangular shape, or it can be an oval shape, but that's where we are going to show the relationship. The first one is the domain, and the second one holds the range. Okay, so what are the numbers I have for the first one, for the x? So I have 3, I have -4, and I have 0. So these are all my domain, and the range is the y. 5, we have -2, and we have 2. So range is the y coordinate. Domain is the x coordinate. And then what I'm going to do is I am showing you the relationship. I'm going to make an arrow from 3 to 5. And that is my relationship. 3 to 5, -4 to -2, 0 to 2. So it goes from the domain to the range. That's the direction in which the arrow is going. So this is called a mapping, also called a mapping diagram. This is one way to show the relationship. And basically when I look at that, I know that my ordered pair is 3, 5, -4, -2, 0, 2. So this is one method of showing a relationship. Another method is with a table. Okay, so I'm going to have a table. And just as it says, we are going to draw out a table with the x and y values. Okay, so I have a table. Okay, and I have the value of x, I have the value of y, and we have, what is this? 3, 5. So 3, 5, -4, -2, 0, 2. And remember, x is the domain, y is the range. All right? Then another way that we can show this is by a graph. And graphing is what we are using as the coordinate system, which we have already done. All right? So we are going to have the x and the y axis. Okay, we have the x and the y axis, and then we are going to, this is my origin, all right? So we have 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Okay, and so if I am graphing this, it is 3, 5, so I go to 3 first, and then I go here, and that is 5, and this is my 3, 5. And then if I have -4, -2, here's -4, and -2 is here, so this is where they meet. And this is -4, -2. That is my ordered pair. And then I have 0, 2. So here is 0, 2. So look, as you can see, I have graphed it. And this is my line, if you're looking at it. There. Okay, so there's my graphing. And then, of course, I can write out an equation. And if I'm looking at all these values over here, so if you're going to make a relationship, we know and we have learned in the past that x is the independent variable and y is the dependent variable because it depends on x. So let's see, what do we need to do to x in order, what do we need to do to x that we can get y, because y is depending on that. So if I look at this, I know that 3 plus 2 gives me 5, -4 plus 2 gives me -2, 0 plus 2 gives me 2. So if whatever x is, I am adding 2 to get the other. So what is my equation? My equation is y is equal to x plus 2. And this is my equation written out for this relationship. All right, so these are the different ways that I can show relations between the x and the y, where x is always the domain and y is always the range. All right? So let me take you to my whiteboard, and here's a question. Are representations of a relationship, and we are using these values that are provided, and we're going to express the relation as a table, a graph, and a mapping, and we're going to determine the domain and the range of the relationship. Okay? So in order for me to map this, as it's saying for part A, we are mapping it, we are making a graph for it, we are creating a table. So for this data, I'm going to now take you to my board so I can again demonstrate how to create this. Okay, so here we are, and let's do the mapping first. So I have the domain, I have the range. So let's look at the domain. I have 2, 0, 3, and -3. So I'm going to put these values, 2, 0, 3, and -3 is my domain. And my range over here, I have 0, 4, and I have -5. 2 times over here, but I'm going to write it down 1 time. So I have 0, I have 4, and I have -5 as my range. And then I am going to draw the arrow from the domain to the range. So 2 to 0, 0 to 4, and I have both 3 and -3, both are going to -5. Okay, let me make this arrow a little better. We can just make it going to the same place like this. There we go. They're both going to the same, which is -5. So there is my mapping diagram, right? Let's look at the table, and we can write it down as, starting, what is this? -3, -5. We can do either way, but okay, sure. -3, -5. Okay, then I have 0, 4. I have 2, 0. And then I have 3, -5. 3, -5. So I'm just trying to organize this from negative to positive. So -3, 0, 2, 3, and then whatever the ordered pair is. So whatever the range, we are going to stick on this side. All right? And then if I'm graphing this, just look at the ordered pairs. I have 2, 0. Okay, so this is going to go here. 2, 0 is here. This is 2, 0. I have 0, 4, which is here. I have 3 and -5. So this is 3, and here is -5. Okay, so this is 3, -5. And then I have -3 and -5. So this is -3, goes all the way down again over here. And this is -3, -5. So here are my ordered pairs that I have graphed out. So once again, the domain of the relationship. Okay, so the domain will be written as a set. And this is going to be, we're going to put it in the correct order from the smallest to the largest. And we have -3, 0, -3, 0, 2, and 3. And that's my domain. My range over here, so this is the domain. My range is going to be a set of, we have -5, and we have 0 and 4. So once again, I've just put those numbers in the correct order. Okay, so That is basically representing relationships of the domain and range of this set of data. All right, so let's go back to my whiteboard, and I am going to look at this problem. So let's look at this and see what it is asking. So it is saying we're representing the relation again. So the check lists the ordered pairs in each relation. Okay, so here we go. Now, let's look at the table first. And we are again going to go from the smallest to the largest. Okay, and so if I look at the table, my ordered pair. So what are my ordered pairs here? I have -2 and 3. I have -1, -5, and I have 4 and I have 7. So look, -2, 3, -1, -5, 4, 7. So that is my ordered pair for the table. Let's look at the graph. Okay, so we can see from here and here. Okay, so what is this one? This is -2. The 1, 2, 3, 4, that's -4. Okay, so for the graph, I have -2, -4. Then I have, what is this one? 1 and 3. Okay, this is -1 and 3. And then we have 1, 2, 3, 4, 5, and up 1. So this is 5, 1. Okay, so those are my ordered pairs for the graph. So you have -2, -4, and then you have -1, 3, and then of course we have 5, 1. So if you remember when we had done coordinate graphing, the quadrant 1, which is up here, this is positive, positive, ordered pair. Quadrant 2 is going to be negative and positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. And that's how the ordered pairs are. So just a quick refresher for that. Let's look at the mapping diagram. All right. So we have -6, -1, -6, -1. We have 1 and we have 5. 1 and 5. And we have 5 and -1. 5 and -1. So these are the ordered pairs in each of those relations. All right. Now, we are going to talk about graphing now. So let's look at this one. Analyzing graphs of relations. Graphing the total time driven during your driving course can help you visualize the progress. A relation can be graphed without a scale on either axis to show the relationship between the independent and the dependent variables. These graphs can be interpreted by analyzing their shapes. Okay, so let's look at this one. I need you to remember one thing from 6th grade that we had learned. Time is always going to be the independent variable. Okay, that is why the independent variable always goes on the x-axis, and time is always the independent variable. Okay, so let's look at this one. And you can see the values in the domain correspond to the independent variable in a relationship. The independent variable, which is usually x. Okay, so this is my x, this is my y. Independent variable is usually x. Okay, this is my independent variable, and we know that y depends on x, so y is the dependent variable. And I need you to remember that time is always the independent variable. Okay, so what is the independent variable here? Of course, because we're talking about time, days is my independent variable. And then when we look at the dependent variable, once again, the values in the range correspond to the dependent variable. And so what was the independent is also what? Domain, because it is affecting your range. And the dependent is the range in the data set. Okay, because y is dependent on x. And so the range corresponds to the dependent variable, and the dependent variable is the variable in a relation, usually y, with values that depend on x. And in the graph shown, the dependent variable is the driving time. That depends on the number of days. Okay, so we are now going to do an interpretation of data. We are going to analyze the graphs. Okay, so let's go on and look at this one. And so it's saying the graph represents the number of text messages sent by Nora throughout the day. Identify the independent and dependent variables of the relation. Describe what happens in the graph. Okay, so let's look at this problem, and we are looking at the graph over here. Which one is the independent variable? I just told you that time is always the independent variable. X, this is x. So this is my independent variable. And the text messages sent is the dependent variable. This is the dependent variable. Okay? And now we are looking at this data, and we are going to analyze it. What do you see over here? Okay, what is happening in the graph? So as you move from left to right along the graph, from left to right, what do you see about the text messages? The time has increased, and the number of text messages sent increases until what happens here? It becomes a horizontal line. A little bit here, and then it becomes a horizontal line over here. The horizontal line means that time is increasing, but the text messages sent remains constant. Okay, text messages sent remains constant, but even though the time has increased. Okay, and so during this time, Nora stopped sending text messages. So if you think about it, maybe you are in my math classroom where you're not allowed to use a cell phone. So that could be, one of the reasons. I'm just giving an example. So that's the time that you stop texting each other. And then the other times are times in the day when you're in the hallway, you're moving around, so your text messages are more. But in the classroom, for any subject in the school building, the phones are put away, so text messaging is not going on. So this is just an example of why it is flat over there. Okay, so during this time, Nora stopped sending text messages. Okay, and then she continued to send text messages until she stopped again for a period of time. So finally, so here she has stopped, and then she's sent some more, then she stopped for a period of time, and then again she began sending text messages. So just looking at this graph, I can analyze it based on that. Okay, so let me do a problem like this one. Okay, so we are looking at this and we are identifying the independent and the dependent variables of each relation. Okay, the average price of a ticket to an amusement park has steadily increased over time. So the average price of a ticket is the dependent variable. It's the dependent variable because it depends on the time. Time is always the, what did I say? Independent variable. So time is the independent variable. Okay, and let's look at the other one. The air pressure inside a soccer ball decreases with time. So what is time again? Time is the independent variable, and air pressure is the dependent variable, Okay, so just doing a quick review of independent and dependent. Okay, let's look at another graph. Let's look at this graph. And then we are going to analyze and see which graph is fitting the situation. So, airplanes. After an airplane takes off, its altitude increases rapidly. So let's see, where is it increasing rapidly? Well, not as rapid over here. So this does not look correct. Okay, so I'm just going to mark off where it's not looking correct. Okay, so this is not increasing rapidly. So I'm going to take this off. Yes, this is going rapidly. Now let's see what it says. So it's either A, it's either B, or it is D. Then look. Once it reaches the desired altitude, it continues to fly at that level for a short period of time. So it can be this, it can be this, it can be this. Now let's continue. Then the plane's altitude fluctuates slightly due to turbulence. In the first one, is there any fluctuation? No, it's just straight, right? And we know that, on a plane, you're going up and down because of fluctuation and, the winds, etc. So this is not correct because this is not a fluctuating graph at all. Okay, so this is like way too much fluctuation. So this would be a very scary flight, to be honest. So this is not correct. So this one here, this is correct because this is showing that slight turbulence. All right. And then finally, the altitude decreases quickly as the plane lands. So which graph best represents the situation? It would be graph B. Okay, so that's basically what we're doing. We're looking at the graph and then we are analyzing that data. All right, now, let's look at this one. Okay, so in this one, traffic is talking about traffic. Kane notices that traffic congestion on his street on weekday mornings depends on the time of day. He draws a graph to represent the relationship between the time of day and the volume of traffic congestion on his street on a weekday morning. Analyze the orange segment. Select the statement that describes what is happening during this time. So I can look at the orange segment. It is going downwards. Since it's going downwards, it means there is a decline, right? So let's look at the options. The first one is saying that traffic congestion is steadily increasing at a very fast rate. No, because we are talking about this segment here. When it's going down, it is not showing an increase. So this is not correct. Okay, so next it's saying that the traffic congestion is constant and very light. Is this constant? No. If it was constant, it would be a straight line like this. But it's going down. Okay, the third one, traffic congestion is constant and very heavy. Again, it's not constant. Okay, it's not heavy. And then it's saying traffic congestion is decreasing at a steady rate. And that is correct because it is going down. So that's a decrease. All right. So option D is the correct choice over here. All right. Then the next thing I want to talk to you before we do this is the scale of a graph. Okay, is the scale of a graph. So when graphing on the coordinate system, the scale of a graph refers to the distance or interval between tick marks on the x and the y axis. For example, like mostly, on the x-axis we'll be like putting the tick marks 1, 2, 3, 4, 5, or on the y 1, 2, 3, 4, 5. But I can also have, let's say on the x-axis, I can have 5, 10, 15, 20. But all those intervals need to be exactly the same. It's got to have the smallest number and the largest number in the data set to be included in the intervals that we are selecting. Now, x and y can have different intervals. For example, x can be 5, 10, 15, 20. And y-axis, I can have 10, 20, 30, 40. It's okay. But whatever interval I'm using needs to be the same on that axis. Okay? So, let's look at this one. And if we are looking at the numbers over here, we've got to pick that what is the x coordinates and the y coordinates are between what, and so what should the scale of the graph be? So if I'm looking at the x coordinates, let's see, the smallest x coordinate is -36, right? So the smallest x coordinate that I see over here is -36. So I have -36. And then we look at what is the largest one that we see over here. So for the x, so -36, 25, 35, -10, so I have 38. So we have and 38. Okay, so that's the smallest and that's the largest. Let's look at the y coordinates. Let's look at the y coordinates. Just like we have x coordinates, we have y coordinates. And let's look at the smallest and the largest. So what's the smallest in the y coordinate? I can see it is -91. Okay, please remember the first one is always x, second is y. And that's basically what I'm looking at when I'm looking at the x or the y. Okay, so here, just wanted to show that to you. So the smallest is my -91, and then my largest one, as I can see over here, is 95 and 95. All right, so the x-axis should include values from about -40 to 40, so that all of this can be graphed. And then if I look at the y, it should include values from, let's say, -100 to 100. And so on this one, we're talking about from 40, a scale of what can I use? I can definitely use a scale of 5. Okay, a scale of 5. And for the y axis, I can use a scale of 10. Because look, 5, 10, 15, 20, 25, 30, 35, 40. So that would be good to use on the x. And for the y, because the numbers are, almost, if not over, the double the amount. So that's why I can just do 10, 20, 30, 40. And that's the scale that I would use. You should know how to use those appropriate scales. And then the last thing what we would do is graph it. So I'm going to show you one which is already graphed in order to save time. But we know that when we are graphing, we graph x before y always. And we're going to take the ordered pairs and we're going to graph it. And this is what it's going to look like. So look. All right, this is like 5, 10, 15, 20, 25, 30. And this is 10, 20, 30, 40, 50, 60. And that's the scale that we were just talking about. And then we've gone ahead and we have graphed it. Okay, so let's go ahead and do a problem like this one. We're looking at the numbers here. And we're going to select the most appropriate scale for each of the x and the y axis. Okay, so let's look at the x and the y. This is x, y, x, y, x and y, x and y. So we are going to look at what is the smallest, the most appropriate scale for the x and y, but we have to look at what's the smallest to the largest numbers in the x. Okay, so if I'm looking at this, I know that -10 is the smallest number here. And then what is the largest number that I can see? It is going to be 16. So which scale would be a good one in this? It would be this one. Okay, so -12 to 18 would be good to use, okay, because that is a little less than -10, and it is a little more than 16. So that would be a good scale to use. Okay, now let's look at B, the y-axis. And then looking at this again, the x and y, the most appropriate scale that I would use for this one, I can see I have -27, so this, and then I have 32, so therefore this one is going to be a good scale. That's going to be a good scale to use. All right. Now, the next one, I am going to show you the graphing and everything, because once again, it does take time to graph it, but by now I know that you know how to graph, but I'm going to go ahead show you what I'm talking about. Look at this one. So the table shows the total snowfall in January for Boston. Okay, so let's look at this. We are going to choose an appropriate origin, going to choose an appropriate scale, and we are going to graph the data points on the coordinate plane. So if I am choosing an appropriate origin, we are going to let the x-axis represent the years since 2005. And so we talked about that x-axis is always time. So this is my x-axis. All right. And so since 2005 and then onwards, and that's what we are going to let the x-axis represent. And the y-axis is going to represent the total snowfall in inches. Okay. And then the origin 0, 0, the ordered pair 0, 0, represents the year 2005 and 0 inches of snow. Okay, so we're going to choose an appropriate scale. The total snowfall is between 1 and 43 and 300. So 4300 and 1. Okay, so because of that, the y-axis should include values from 0 to 45. So that's how the y value is going to have from 0 to 45. Okay, and have a scale of 5 inches. So let me go ahead and show you the graph. And here it is. And these are the years since 2005. So 2005, 2006, 2007. That's basically what this is. And then we had said that the graph should be from 0 to 45, and that's basically what that is. And then we just graphed those the ordered pairs in here. Okay, so just look at that. And we are going to go ahead and do one last problem. Last problem. Going to interpret scales and origins. And social media, the average number of posts per day on a social media site each year is given in the table. Interpret the meaning of the axis, scale, and origin of the corresponding graph of the data. So let's look at this. Let's look at the table and the graph. Okay, so the x and the y axis. The x and the y axis. So the x-axis represents the number of years since 2008. Okay, number of years since 2008. And because it is not appropriate to start at the year 0. Okay, and the y-axis represents the average number of posts per day in millions on the social media site. Posts per day in millions. And the x-axis has a scale of 1 mark, which is equal to 1 year. So 2008, 2009, 10, 11, 12. So it's like per year. So that is why I have put the tick marks of just 1. Scale is 1. And the y-axis has a scale of 1 mark is equal to 50 million posts. So the origin 00 represents the year 2008 and 0 posts in that per day for that. Okay, and that's basically what your module 3.1 is about. We are learning to represent relations between the domain and the range. Remember, domain is x, range is y, and we're representing the relationships as a mapping diagram, a table, a graph, or an equation. So that concludes module 3.1.